Now that you know a bit about frameworks in Android and Java in general, let's start diving into a discussion about Android concurrency frameworks. So we're going to start out by motivating why Android needs concurrency and why we need concurrency frameworks. So first, let's motivate concurrency in Android. It should come as no surprise, based on other things we've covered in this course, that many apps in Android, or apps in general, programs in general, can require and/or benefit from concurrency. Most commonly, these kinds of apps perform long-duration operations and/or they access remote resources in the background. For example, apps often, though not always, interact with servers that reside somewhere in the cloud. For example, there are apps that play multimedia content on a device where they're streaming the media from the cloud, either things like music videos or films and whatnot, YouTube videos. It's also very common to want to synchronize the contents of databases on the phone with cloud servers, so email that you might be using while you're offline, contact, which you might update while you're offline, calendars, which you might update when you're offline, the multimedia message service, the simple message service, and so on. These are all things that store databases of content on the phone that need to be synchronized with a cloud service somewhere so you don't lose that information or you can transfer it between different devices. Also could be useful to download and store images, which is a theme we'll come back to a number of times when we talk about the async task framework and show some examples here shortly. You may want to be able to access various web services, such as a weather service or a movie time service, or many other kinds of services for scheduling events, keeping track of your friends, and so on and so forth. Concurrency benefits these kinds of apps by overlapping communication and computations. If you take a look at the earlier lessons we discussed for the motivation of concurrency, you'll see some other good examples. For example, we often want to be able to increase performance of the app by using multi-core parallelization. So you can actually physically run multiple computations at the same time on the multi-core hardware. We might also want to improve responsiveness by running long-duration operations in background threads, thereby keeping the user interface thread free to interact with the user without having to block and give an annoying hourglass or a spinning wheel that indicates something's not reachable or something's not accessible at a moment. Yet another motivation is often to simplify the program structure by allowing threads to block synchronously without perturbing the user interface thread and causing application not responding errors and so on and so forth. In general, the use of threads can often, not always, but often yield a more natural flow of control within an application and be able to allow different parts of an application to collaborate with each other without having to worry about deadlock or live lock or blocking or other kinds of problems. Now that we've talked a bit about why apps might need concurrency, let's talk about why Android needs concurrency frameworks, why it can't just use the frameworks that come out of the box from Java. So it turns out that Android's concurrency frameworks are used to address various design constraints. So for example, if you have a long blocking operation or a long duration operation in the user interface thread and it blocks more than just a couple of seconds, the underlying Android framework, the activity framework, will throw an application not responding dialog up, indicating that there's something wrong with your app, that it's not responding in a prompt and efficient way. So it'll actually give you the option of closing it or waiting for it to respond, which of course it may never respond because it may be blocked indefinitely. So that's one thing that we want to be able to deal with. The Android framework explicitly doesn't let threads block in the user interface thread for any length of time, for any long length of time. In a not unrelated way, networking calls, reading and writing, for example, from the UI thread is also disallowed by default. If you try to send or receive data over sockets, for example, then by default you'll get an exception, the network on main thread exception. Now there are ways to work around this, but it's not advisable. Another constraint is that non-user interface threads are not allowed to access user interface toolkit components directly. And that's because the UI toolkit components are intentionally designed not to be thread safe. They include no locks. They're designed to be run only in the main thread or the user interface thread. And there's various reasons for that, primarily having to do with not requiring application developers to learn how threading and concurrency works, number one, and number two, in order to avoid the overhead of having to lock all access to shared data structures by the user interface toolkit components. So as a consequence of these Android design constraints, the Java concurrency mechanisms we talked about earlier in the course simply can't address all those issues. There's something more that's needed. And what more that's provided is the Android concurrency frameworks, the handlers, messages and runnables, or Hammer framework, and the async task framework, both of which we will address in more detail. If you want to see some examples of what happens if you don't follow these design constraints, if you don't respect or abide by these constraints, take a look at the Buggy Downloader app. This is an app you can download that tries to download images, but it has glaring bugs in each of its different activities that it provides. The Buggy 1 activity will throw an exception since the image is downloaded in the user interface thread, which, as I mentioned before, is not supported by default. You have to do additional things to support that, and it's really not a good idea. The Buggy 2 activity will throw an exception since that implementation has a user interface component that's accessed via a background thread. So if you try to do that, if you have a background thread that tries to write to a user interface component, then you'll get this weird exception that's going to be called from wrong thread exception. And the message says only the original thread that created a view hierarchy can touch its views. So that's a somewhat obscure way of saying you can't access the UI toolkit components from anything other than the foreground thread. So that's the end of a quick overview to motivate why Android needs concurrency frameworks. It needs them because it can provide all the other benefits we get from concurrency in general, and to work around various constraints that were intentional in the Android design.